Welcome to VLearn. Today we will start from Block 1, Unit 3, and this is the Inter-Process Communication and Synchronization unit. In this block we will discuss about the how two or more than two processes are discussed with each other throughout the processing period, throughout the execution time. Now we will discuss about the topics which we covered in this unit: inter-process communication, shared memory system, message passing system, inter-process synchronization, serialization, mutex, about the mutual exclusion of processes which are collide with each other when they are acquiring a single resource which is held by another process. Next one is critical section, is the continuous waiting state, or you can say when two or more than two processes are collide to each other for acquiring a single resource. Next one, Decker's solution for mutual exclusion, and the next one is Becker's algorithm. Now we start from semaphore. Semaphore defines how to resolve the problem when the processes are going inside the critical section and how they are handled to resolve that kind of problem and that kind of situation for removing the problem. So all of these conditions help us to resolve the critical section problem and how to come out from that kind of problem, from where we have to go for that purpose to resolve or to smooth working of the all processes throughout the execution and processing of the system. In this we have start from concurrency, communication among processes, like more than one processors processing number of tasks simultaneously at the runtime, and they need to communicate with each other. Then that time we required kind of communication between more than one or two processes. In this, these processes may be required for sharing the number of resources for completion their task, for completion their execution process. At the same time, when we are allocating some resource to number of processes for sharing data, sharing information, some processes are there which are waiting for the execution or for entering into the running stage. At the same time, we required a synchronization of multiple processes and allocation of processor time, which we discussed in the previous section or previous class, in which we decide how much time allocate to particular process and how we execute number of processes. Now the concurrency allow us to multiple application or multi-programming structure for execution or processing number of tasks. In structure application can be a set of concurrent processes which are running together, which are executing simultaneously or parallelly for completion or achieving a common goal, or maybe goal can be different. Now the next one is operating system structure. Operating system is a set of processes or threads which are executing or completing particular task or doing some processes for achieving a common goal for completion of the task. That kind of processes are always running inside the computer system, which are controlled by the operating system for doing the smooth working of the system or their efficiency or their maximum utilization of available resources. Now this is the problem of difficulties or problems in the concurrencies. First one is sharing global resources. Number of resources which are required to share by number of processes, but sometimes some processes are much more and the number of resources are very limited. In that case we have to wait, or the processor have to wait for allocation or allocated resource to be released for the further next resource. So that time we have to take decision or set the priorities, which one resources have the higher priority and which one require the most suitable resources. That on that basis we have to allocate the number of resources to the number of processors or on the basis of their requirement or their request, and we can follow the kind of allocation or scheduling algorithm for allowing them for sharing resources or for requesting and responding the process's task and their respondent. The next one is programming errors difficult to locate. In programs, sometimes we have very logical or very symmetrical problems in the programming sense, and if we are going to correct a single problem, then it may cause of multiple errors, and in that case we have to very careful for removing or relocating the errors or resolving the problems in the programming, and sometimes it is very much difficult for resolving that kind of problem in concurrency or parallel system, in that we are executing multiple processes and running multiple processing simultaneously. Next one is competition among processes for resources. In that case, we have the number of processes which we discussed in the previous slide. We have the number of processes and number of resources, but when we have number of limited resources and n number of processes, in that case we have to decide which have the higher priority and allocate that particular resource to that particular process, or on their requirement basis, on their higher priority basis, on their request basis, on first come first serve basis, which we discussed in the previous class. Allocation methods and scheduling algorithms are there. In that case, for try to resolve any kind of exclusion or collision between the number of processes, these kind of collision may cause of the deadlock, and deadlock is the continuous waiting state. In that case, the problem becomes or enter into the critical section. So we can say when processes are continuous waiting, that is the critical section problem. In critical section problem, we have number of processes which are waiting for a particular resource and which are in a continuous waiting state. So only one program at a time is allowed in its critical section. And the next one is example, only one process at a time is allowed to send command to the printer. This kind of problems which are comes inside the concurrency control or mutual exclusion, when we have a single printer and n number of computers for sending the command. If number of computers sending commands simultaneously to a particular printer, in that case the printer have to decide the priority or set the priority or make the queue. On that basis, it will process the every command sequentially or accordingly. It gets the request from the number of processes. The next one is problem that can occur in mutual exclusion, that is the deadlock and starvation. Deadlock problem when number of processes is waiting for the number of resources which is held by the another resource, and you can say in that case a single resource holding by a single process and requesting for another process and requesting for another resource without releasing the existing resource. And starvation is kind of problem in which it is requesting for more and more resources and holding every resource and not going to release. So every process, if doing the same thing, so we do not have as much resource to allocate the number of process to the number of resources. In that case, we are shorting the number of resources for allocation to number of processes. This is called starvation. And the next we have inter-process communication. Suppose there is a process for addition of two numbers like A is equal to B plus C, and the next task is D is equal to A into F. So there is a kind of communication is required between these two statements. If we are going to be execute the program, then first the process is executed is A equal to B plus C, then we require a sum of two variables which are the B plus C and the result stored into the A, and in the same sense this result is required for processing the next statement, that is the A is into F and that is stored into D. So that kind of communication is required between these two processes for sharing the information. The result of one process is the input for the another process. In that case, some communication is required or some processing is required. Same manner when one process giving some command or giving some output, and that is the input for another process. In that case, we have the communication between the two processes there is the kind of mechanism for sharing the information and data for completion the task, like mechanism for process to communicate and synchronize their actions with the another processes for completion or achieving their goals. Message system process communicate with each other without resorting to shared variables and without collision in the resources. And the next one is we have to at least two primitives, send or receive and receive or send. This kind of variables help us to initiate or to close the communication. When we have to start the communication, we will send an acknowledgement to check the availability of the second process or to the second computer, and after the acknowledgement we can send the data, and after closing or after completion of the data which we have to send, we can send the again acknowledgement for closing the communication, and it will receive the same manner acknowledgement from the second end and getting the response and closing the communication. So when we have to start the communication between two or more than two computer or nodes, we have to require some kind of messages to acknowledge between all the processes, and for closing the communication we have to again require some kind of messages which acknowledges to all of them the communication is going to be closed. So that kind of processes are there for initiation or for communication between one or more than one computers or nodes or processes. Why that kind of IPC is required is the next topic. IPC stand for inter-process communication, and we can give some answers or some examples in that which we discussed earlier, as like information sharing, we need a IPC inter-process communication. For resource sharing, for computation speed up, synchronization, modularity and convenience. These are some points for sharing the data and for requiring the IPC inter-process communication between two or more than two processes. And now come to the next topic is IPC mechanism. There is IPC mechanism in which we can pass the message passing, send message to other process or receive message from them. Next is share a memory area with other processes for storing or retrieving or accessing the data. Next one, synchronize itself with other process by means of semaphore to make the understanding, to make the compatibility between more than one process or more than one CPU which are sharing and which are communicating with each other for achieving the goals or for completing their task. Now come to the next process is message passing mechanism. In this there is two kind of communication link. One is physical link and the second one is logical link. In physical link there is we required a physical connection between two or more than two nodes or computers for sending or sharing the information, and the second one is the logical, where we establish a kind of communication between them, that is a logical manner, which is as compared to physical. There is no physical devices are required for establish the communication. In exchange message, two primitive operations for fixed variable and sized message passing, that is the send and receive. If we are sending some data, we need to send acknowledgement for send acknowledgement, and if we are going to receive the data from second end, then we require a receive kind of acknowledgement, and after the communication establishment or completion the communication, we have to send kind of acknowledgement. By that way the other person know the communication is going to be closed. Now the next topic is shared memory system. In that system we share the number of resources for storing or accessing or retrieving the information in the memory. If n number of processes are going to execute n number of tasks but they are sharing the same memory, they need to store or access the data from the same memory, and this is the utilization, and this is the efficient utilization of memory which is installed in our system or in our process. Shared memory system require communication process to share some variables. The process are expected to exchange information through the use of these shared variables. In for example, if we are accessing or mailing some data and we are listening some song from the same memory and attaching some files from the same memory for sending email, this is a kind of sharing of memory between two or more than two processes. You can do the same thing for achieving the shared memory process. A critical problem occurring in shared memory system is that two or more processes are reading or writing some shared variables or shared data, and the final result depend on who runs precisely and when. Which process requesting first and which process is completing first, that kind of accessing or retrieving or storing kind of applications or task. Such situations are called the race conditions, in which every system is going to be compared with other processes for accessing or storing the data. Next one is inter-process synchronization. If we are doing the multiple tasks at the same time and everyone doing the independent or dependent task, in that case we need or we require some kind of synchronization between the number of processes and number of tasks. Inter-process synchronization means when two parallel threads attempt to update the same variable simultaneously, the result is unpredictable. The value of the variable afterward depend on which of the two threads was the last one to change the value. This is called a race condition. Which one start first and which one updated at last. This is a kind of race around condition. What we need in a multitasking situation is a way of making such situations predictable. This is called serialization. When we are making the sequence and allocating the number of sequence to the number of processes, which one execute first and which one execute at last. This kind of situation, when we are trying to handle the situation of data collision, situation of resource collision, situation of accessing collision or mutual exclusion, in that way we want to make secure our processes, secure our data, secure our memory for the collision or for preventing the collision. Now the next is serialization. Key idea in process synchronization is serialization. There are essentially two strategies to serializing process in a multitasking environment. The scheduler can be disabled for a short period of time to prevent control being given to another process during a critical action like modifying or shared data. The next is a protocol can be introduced which all program sharing data must obey, which is must be required thing or kind of protocol is required for sharing data, which is followed by the every process for doing the task. The protocol ensures that process have to queue up to gain access to shared data, which may access in a queue, which may access in a particular sequence which is allocated by the process and the priority set by the operating system. This kind of process and this kind of methodology help us to avoid the deadlock condition, to avoid the congestion in a process execution, in a completion of processes task. The next one is Mutexes. You can say mutual exclusion. When two or more processes must share some object, and arbitration mechanism is needed so that they do not try to use it at the same time. When two or more than two processes trying to access same thing or same process, same memory at the same time, then that kind of problem will occur, which is called mutual exclusion. On a uniprocessor system with non-primitive scheduling, mutual exclusion is easily obtained. The process which needs exclusive use of a resource simply refuses or relinquishes the processor until it is done with the resource. You can say there is 4 processes like P1, P2, P3 and P4, and there is only single resource, suppose R1, and they are requesting for R1 resource like at T1 time. So P1 request for R1 resource at T1 time, P3 request for R1 resource T1 time, P4 required R1 resource T1 time, and P2 is also requesting or required to access the R1 resource T1 time. So this is the mutual exclusion condition or situation when every process is colliding and every process requesting for the same resource at the same time. A similar solution works on a primitively scheduled uniprocessor. The process which needs exclusive use of a resource disables interrupt to prevent permission until the resource is no longer needed. Mutual exclusion can be achieved by a system of locks. A mutual exclusion lock is called a mutex. The idea is for each thread or process to try to obtain locked access to shared data, get mutex and release mutex. Get mutex for locking and release mutex for unlocking the resource or process. Now, the solution for mutex is a critical section is a part of a program in which is it necessary to have exclusive access to shared data. The characteristic properties of the code that form a critical section are: first, code that refer one or more variables in a read, update, write. You can say more than one processor have the rights for read, update and write fashion, while any of those variable is possibly being altered by another thread. Suppose P1 and P2 process have the read permission, P3 and P4 have the write permission. If any next or any other process enter into the system, suppose P5, and update the system or alter the variables or alter the value, that kind of value is accessed by the another process, but they do not want to access the update value. So this is the problem when the another system and another process enter without any permission into the system. This is the critical section problem when more than one processes are accessing at the system for a same resource, but they are not going to update, and the another system is come into the system and enter into the situation and update, and the access or update value is accessed by the another process, but they want to access the previous value which is not updated or original value before updating the value by another process. The next is critical section mutex solution. In the same way, code use a data structure while any part of it is possibly being altered by another thread. Next, code alter any part of a data structure while it possibly in use by another thread. There is also some drawbacks. First, masking interrupts can be dangerous. So this is the situation when we don't know which system and which process entering into the system and updating the value. Next is, since interrupt will continue to be serviced by other processors, so all processors would have to be switched off. When someone accessing the system and other processor enter into the system for updating the value, then we need to all processor would have to switch off. It is too harsh when another process interrupting continuously and one process executing their task. Next is Decker solution for mutual exclusion is uses busy waiting works for only two processes. Basic idea is that the processes record their interest in entering a critical section and they take turns when both need entry at the same time. When two or more than two systems want to access or enter into the critical section, they have to wait for their turn and enter into the system. Decker solution to the mutual exclusion problem require that each of the contending processes have a unique process identifier which is called me, which is passed to the wait and signal operations. So Deckers want to say, if one process is going to executing a process, it should be passed the signal like waiting and for requesting to wait, or for completion their task, or for acknowledgement after completion their task for another process to allow them to enter into the system for execution or completion their task. Baker's algorithm. In Baker algorithm handle critical section problem For n process as follows. Before entering its critical section, process receive a number or sequence number. Holder of the smallest number enter the critical section. Here number represent the time required by a particular process. If process Pi and Pj receive the same number, then we have to compare which one is greatest and which one is smallest. Allow the smallest number to enter first. The numbering scheme always generate numbers in increasing order of enumeration like 1, 2, 3, 4, 5 and 1, 2, 3, 3, 5. And if more than one process have the same number, then the allocation method is on first come first serve basis. In Baker's lexicographical order process is used and followed for allocating a ticket, for shared data or for accessing the same data, and we have to use the boolean flags for acknowledging them. The system is busy or free, like 0 and 1 you can use 1 for busy and 0 for free. Data structure are initialized to false and 0 respectively for acknowledging the another. The next topic is semaphores. In this special variable called a semaphore is used for signaling. If a process is waiting for a signal, it is suspended until that signal is sent. Next is wait and signal operation cannot be interrupted. Next point, Q is used to hold process waiting on the semaphore. In this scenario or in semaphore, it want to say and it is going to use kind of signals for permission and for allowing the another processes to entering into the system by using some kind of signals, by using some kind of flags. If one process is executing the request or interrupt generated by another process, getting the response as like waiting, and they are not allowed to enter into the system or they are not allowed to interrupt the another process which is executing at the same time. Q is used to hold processes waiting on the semaphore. Semaphore is a variable that has an integer value, may be initialized to a non-negative number. Wait operation decrement the semaphore value and signal operation increment semaphore value. Semaphore value is incremented when the number of signals is getting increased and the number of processes getting executed and completed. The operation decrement the semaphore value. Now come to the next topic,